All right, one more. This one's got a little bit going on, yeah? This one's got a little bit going on. So right off the bat, should I write everything in terms of sine or cosine? Well, that's been done. So that's not going to work. Okay, we're not going to be able to do that because everything is in terms of sine or cosine already. What about manipulating and substituting Pythagorean identities in for squared terms? Do we have a squared term in this problem? Indeed we do. We have cosine squared. So, it is possible to do this. Should we? Let's wait and see what else we can maybe accomplish. What about factoring out a common term? And we talked about that. When can we factor? When we're adding or subtracting two or more terms. Are we adding or subtracting two or more terms? We are. There's a minus sign here. Okay? So we also have the ability to look at this and look at this and see if they have anything in common. Do they have a common term? They do. Sine x. Okay, so I've got two options now. I could do this, or I could do this. Find a common denominator and combine fractions. There are no fractions. Factor by grouping. You need 4 terms to factor by grouping, so we're not going to do that. Like I said before, this is very rare. We'll do this. I'll point this out to you when you least expect it. Or decompose a fraction. There are no fractions in this problem. So one of these two tools is what we're going to do right off the bat. And you can do this problem using either one of those tools. Okay? What I'd like to do is this first one. Let's manipulate and substitute a Pythagorean identity in for a squared term. What am I talking about? Here's what I'm talking about. Here's the squared term. I'm going to use the Pythagorean identity that includes cosine squared, and I'm going to move some pieces around until I get just this statement. Okay, so here's what I'm going to do. You ready? You ready at home? Are you guys ready? This is going into like the margin. Okay, I'm going to call this the margin, meaning this isn't going to go in line with the proof that I'm doing. So what we're about to do, don't put this right underneath what you just wrote. Go off to the side somewhere. Okay? Here's the margin. Here is a Pythagorean identity. The squared term that's in our problem is this, right? The blue piece. So what I want is I want to take this and I want to isolate that. I want a statement that says cosine squared x equals, and then whatever I can get it equal to, I'm going to put that in its place. So how can I isolate this? How can I get this statement to just say cosine squared x? By subtracting this over to the other side. Why am I subtracting it? Because that's the opposite of addition. So by subtracting this over to the other side, it's not over here anymore. So we end up with 1 minus sine squared x. So this is equal to this. These are the same exact thing. So when I see this in a problem, I can put that in its place. And that's what we're going to do. So now we jump back out of the margin. We come back over here and we say, okay, now instead of that, I'm going to write that. The rest of this has to still be here. Okay? So there's the manipulation and the substitution all in one step. Now, what did I say about after we use the tool, we math it? After we've used a tool, after we've done one of these things, don't immediately go to another tool. Look at what you can do to this. What can you math out, right? Well, we've got this touching these parentheses, and inside the parentheses we've got some stuff going on. So I can distribute this here and here into the two parts that are inside that quantity. And if I do that, sine x minus, now that's sine squared, and I'm multiplying sine squared times sine. So how many sines would that be? 3. Sine cubed x minus sine x. And we're almost done. It's hard to tell because you're kind of overwhelmed at this point, but watch. Ignore everything we did to get to this point. Because now this is where we are. Ignore everything else. Because what we did is in the past, right? What could I do now when you look at this and you see a sine x, a negative sine cubed, and you see a minus sine x, right? Think about like terms. I have a sine x and a minus sine x. Those are opposites. What happens to opposites? Right? They go away. So we have this left over when these guys cancel each other out. Right? That's stepping our game up a little bit. They do get harder than this. Okay? But that's pretty simple compared to what we started with. Look at what we started with. Sine, cosine squared, and we end up with just one term. It has a cubed, I get it, but it's just one term, and that's simple. Okay? Fiend.